Welcome to our professional training event. I see some familiar faces, so who's been here before? Welcome, we appreciate you coming back. And who's here for the first time? Oh, thanks, you got a nice combination of people. So I thank you guys for coming. We're going to have an incredible day today.
B12, they're going to, how many vegans do you hear die of heart disease? I mean, think about it, right? So, I mean, I've heard a lot. Like, so it's one of those things, if I see someone coming in demonstrating on different testing, high homocysteine or liver congestion or heart issues, I start asking, like, are you getting enough B12? Because that's your converter. So it's one way that you can look at it. Okay? MAT creates SAMe from methylene. So this right here, this little pathway where we're converting the SAMe to the SAM, this is also B12. But this is where histamine response comes from. And I'll get back to that. You ever have a child or a person that eats something and immediately breaks out in hives? Okay, that's a SAMe problem. That's a conversion of this protein to this to make the right methyl bodies and donate them.
Just for hives or for any reaction to food?
That's a broad question. I can't say.
A behavioral issue that's immediate, would that be the same category?
That can also be a neurotransmitter issue, but yes, I would say because they do create neurotransmitters. So a broad answer would be yes, kind of.
That's cool.
It's really hard to give any like affirmative, and as you'll see when we get to the actual mutations, it's really hard just to say take these vitamins because it's so individualized. People react. People with MTHFR are so sensitive to supplements. Okay. So the backup system, so to speak, in the liver and kidneys can make methionine from choline and TMG, trimethylglycate, which is basically beetroot. How many supplements do we know for the liver have beetroot in it? Right? Beetroot's a big one in liver supplements, and that's why. CBS removes homocysteine from methylation cycle using B6. So CBS is right here, and it basically takes the homocysteine and dumps it to create glutathione. People that have a deficiency in B12 are going to have a buildup of homocysteine. People that have a deficiency in SAMe are going to have a buildup of homocysteine. People who have a deficiency in trimethylglycate are going to have a deficiency, and they're going to build up homocysteine. So when we see all these things building up, we immediately go to the word disease instead of deficiency. And we should be talking deficiency. And what can we do to help? So these are kind of a guideline for me. I use this little chart and I'm like, okay, so here's what I'm seeing, and here's what I know converts it, so what could this possibly be? Right? And there's a whole other side of that we'll explain. Okay, so the purpose of the pathway, like I said, is to first convert folic acid into a usable form. The reaction from that entire pathway is required for this. Homocysteine to another amino acid, which we showed you back here. So homocysteine to another amino acid, which then creates glutathione. Okay? Methionine, the body uses methionine to make proteins and other important compounds, and it does that through creating this little pathway here. And then we either go to homocysteine and make some amino acids, or we go that way and we make DNA and RNA and hormones and enzymes and all kinds of things that help the body. Whew, you all right? Okay. So, I know this is a big one, but I'm going to pull it all together, because this is the first part, and you don't know anything about the alleles and how they work. So I was thinking, should I play this game I want to play with you guys the other, and I think, yes, we're going to play it because this is super crazy. All right, so here are the two wheels. And, you know, I'm a picture girl, so I like to draw pictures and make sure that people that are visual learners can learn. So B vitamin cycle, methionine cycle. The result of this cycle after it's fed, conversion of folic acid to folate comes through here. If that doesn't happen, the coding is wrong. If that doesn't happen, you have a deficiency that's going to cause an issue, whatever that issue is. And that issue can be, sorry, I'm moving. He's like, don't move, I'm moving. That issue can be DNA, proteins, phospholipids, amino acids, neurotransmitters. So you could be sending the wrong message. You could be creating the wrong cells. Your hormones could be unstable. Your DNA and RNA could be sending the wrong genetic codes, all from that little conversion of MTHFR. So lucky for us, we have companies that convert all this, right? So from here, because of the conversion of MTHFR, and if we have that correct, then we can create, all the way down at the bottom, glutathione, which we use for detox, and we can create healthy cells and proteins as well. Okay, everybody's like, what is she talking about? So let's sum it up. Here we go. Methylation creates methyl bodies. They bind with proteins to do things. Okay? Those things include cellular repair, detoxify, and proper immune function. We're going to walk through each one of those and how it works. The methylation cycle is fueled by B vitamins that have to be properly converted. And there are enzymes that act as catalysts. That list of enzymes I gave you, they all make the reaction happen as long as they have the right Bs and they can convert and everybody's talking to everybody else with the right code. Okay, so everybody all right so far? Okay, good. So methylation, let's start with cellular repair. This is synthesis of nucleic acids, production and repair of DNA. So everybody remembers this, right? Powerhouse of the cell. We learned this in 4th grade. We all thought, why are we learning this? Today's the day, guys. Today's the day you put that 4th grade education into practice. So, what is the point of cellular respiration? So when I went to college, we learned cellular respiration for basically VO2 max. We had to understand how the body recovers. We had to understand like how much oxygen we were creating, anaerobic versus aerobic. That's how I used cellular respiration all these years. And then I got here and I was like, oh, okay, so this is actually for more than just exercise. However, exercise is very beneficial for methylation. So, adenosine triphosphate, ATP, this is what we create from cellular respiration. There's 3 phases. There's glycolysis, Krebs cycle, and the electron transport chain. Right here, this little structure is a mitochondria. This is where all this magic happens. And the whole point to it is to create ATP, which is the energy your body's going to use in methylation. Okay, so when we talk about cellular repair, and you're taking supplements that really help with mitochondrial function, if that's where your issue is, it's going to help. If that's not where your issue is, it's not going to help. Okay? So, glycolysis. This works super heavy with CoQ10. Okay? This is why most diabetics, after a while, are put on a statin because they're not getting enough CoQ10, which is one of the reasons that they might have had the issue with sugar. Okay, glycolysis involves breaking down of sugar. We know how that process works. So we take those 2-pyruvate, the 2-NAD, and the 2-ATP, and it moves on into the Krebs cycle. Okay, at the end of the Krebs, we have the final product, 2-ATP, 10-NADH, lots of chemistry here that, if you guys want to learn all that, that's great. But this is your product, and you can see we have things coming off that the body will use. The body never really gets rid of anything. It likes to recycle, recycle, recycle. The problem when it builds up in our system is not that your body's doing wrong, it's usually we're doing something wrong. We're exposing it to an environment that we put it in that's making it uncomfortable. So then everything goes into that electron transport chain, okay? Now, this system is aerobic. How many people remember Dr. Otto Warburg? Do you guys remember him? Does anybody remember what he did to gain the Nobel Peace Prize? So, Dr. Otto, he was famous for that misquote where they say cancer can't grow in an alkaline environment. Do you remember that misquote? That's not even what he said. He won the Nobel Peace Prize for this, for figuring out that cancer can't grow in an oxygenated environment. He never even said alkaline. We just did that to sell you a green shake. Hey, it worked. So that's what happens with these quotes. So when you see these things come out, you want to make sure that you're saying, is that true, right? So the electron transport chain produces most of the ATP out of all the steps in energy metabolism with a net of 32. If you don't have good mitochondrial strength, if you don't have good cellular respiration, you're not creating enough energy, enough ATP to fuel the next cycle. So when people have low methylation, they have low mitochondrial function. When they have low mitochondrial function, they have low methylation. Okay? Chicken or the egg. And it's up to you to find out what's what. So the electron transport is found within the mitochondria. The goal of the ETC is to produce electrochemical membrane potential, which drives the formation of ATP. So it's all of our energy, and we supposedly get 38 ATP for a 36 net. And why does that matter? It matters here for mitochondria. So how do your cells split? Do you guys remember that? Mitochondrial biogenesis, codes, recycles, all that fun stuff. This is all of the things that the mitochondria do. Energy production. The interesting thing about mitochondria, and this goes back to your question with kids, this evolves over a lifespan. So if you have a child with a methylation issue at the beginning, and you know that the mitochondrial potential can increase over a lifespan, but you start adding things to decrease it, you're going to have two issues. You could have a genome mutation and low mitochondrial function. So here's some of the areas that it's important for: heart, brain, muscles, little systems, lungs, tiny little things. Okay? And what we want is that biogenesis. We want it to split. We want two healthy cells to come out. So if I have 36 ATP and I split, each one has that same electrical potential, right? But if I'm not creating enough energy and I split, now what do I have? Two cells with low function. So now I'm not creating enough energy in 2 cells, then 4 cells, then 8 cells, and which starts to decrease and decrease and decrease. So I always tell people, you can continue making crappy cells, or we can help your methylation, and you can make beautiful, healthy cells that have enough ATP and enough energy to actually fuel the rest of these processes. All right. Any questions so far? Obviously, these are some things that you'll see with clients with low mitochondrial, adrenal fatigue, thyroid, blood sugar, cardiovascular. I usually tell people these are your starter signs. And what do? You're tired, your thyroid's not working right, you go to the doctor, you get a test, and they say, yep, you actually do have some thyroid dysfunction. Here's a pill. Okay? And so that's been our model. And now we have these genome mutations, and that can't be our model anymore, because the pill isn't going to fix it because it's a genetic mutation. So doing things to force the body to try to do something else when it simply just can't because it's genetically mutated, it's not working, and they're finding out it's not working. So they're coming back, and they're looking at this function. Okay, the next process is detoxification and neurotransmitter production. So remember, when we had those 2 circles, at the bottom, I said, would come out and be homocysteine, right here. And then it's going to get converted all the way down to glutathione. And as you can see, it needs certain B vitamins, converted B vitamins, B6, B2. If it goes this way, it's going to create SAMe, and then that's going to go create new proteins, DNA, RNA. If it goes this way, it's either going to be thrown out, or some of this homocysteine is going to be recycled back into this cycle right here. So when we detoxify, our primary goal is this, glutathione. People that have MTHFR or even methylation issues do not produce enough glutathione. So not only are we coding the wrong things and telling our DNA and our RNA the wrong stuff, or we're tired, we're also not producing any glutathione, and we're not detoxifying our body. So all these toxins are building up, building up, building up. Are we exposed to toxins every day?
Yes.
The issue that we're having is that we're exposed to like 10 times the amount of toxins that our body can actually get rid of. And if 50% of the population have a genetic mutation where they can't detoxify, they're going to be very, very sick. So the final enzyme in the process, CBS, basically, he's about right here. He needs B6, B2, and zinc to actually work. But CBS is kind of like the drain. It drains everything out, removes what homocysteine we didn't recycle to make new protein, and we make glutathione. And glutathione is important because it's what? It's an antioxidant, right? It's a huge antioxidant. So now, people that have SNPs, single nucleotide polymorphisms, or genetic mutation like MTHFR, and we'll get into those, will have increased oxidative stress, higher ammonia levels. Has anyone ever got tests back where they have elevated ammonia? What's that telling you now? Seeing a different pattern with it? Like, oh, there's high ammonia levels. What could that possibly say? Maybe that person's not making enough glutathione. Could be. Okay. This also affects sulfur levels. Polymorphisms on the CBC can also affect the sulfur levels in your body. It's because this methionine is a sulfur-based protein. So when you can't convert it right, you're going to get the byproduct is going to be sulfur. So you can test for that in your urine, and you can look for high sulfur. Okay, you can also smell it. You ever walk into a bathroom after somebody was in there and you're like, wow, and all they did was urinate, right? And it's like, it's very strong ammonia, sulfury. I walk in, I'm like, God, you need some glutathione. You know, that's, I just want to walk over and be like, hi, I'm Tracy. Can I just talk to you a minute? You know, but it just gets creepy, you know. So it's important to check. And so as practitioners and doctors, we like to test like once a year or every 6 months. When you're working with clients with methylation issues, it's testing every time. You have to see what you're doing is working or not working. And because they are so sensitive, and there's a parabola where they feel great, and then all of a sudden you give too much, and now they feel bad again. There's also, people were talking earlier, they had questions on people that like upregulate, right? They're like over-methylators. Remember, the body never does anything wrong. They're not just over-methylators. That's usually a deficiency of niacin or lysine. So there's ways that we can work with those people as well. But keep in mind, if you haven't eaten for 6 months and I come in and I lay out a buffet, she's not going to be like, you know, I'm just going to have a carrot. She's probably going to like walk down that buffet and just load it all in. She's going to rev her engine. And that's what happens with people that have methylation issues. You start giving them supplements and they're starting to feel good. And then all of a sudden they come in your office like, I'm having panic attacks and I'm having anxiety. And people go, oh, you're an over-methylator. And I say, no, you got your foot on the gas pedal, like, right? You're revving up that engine. That's actually a good sign. But let's put in some niacin and some lysine because these are what are called methyl burners. So the high levels of the methyl donors that are in there, they're too much for that person. So we put in some of these things that actually stress the system and burn up those methyl bodies. And it helps with that little parabola of where people are kind of feeling like, oh. And if you start working with people that have this issue, you'll see it, especially in kids. I'll get calls from parents and they'll be like, he is jumping on the furniture and running around the house. He's acting like a lunatic. And I'm like, yay! Not to them. They're like, what do I do? And I'm like, well, we can try some of this. You know, so we'll put in some of those methyls that actually will burn that off. Yeah.
Does that always work, or should you ever be at a point where you back the dosage down with some, maybe too much? Because that happens to me. I'm a
Right.
677 TT and 1298.
Oh, you're the compound heterozygous.
Yeah,
Nice.
and I started on.
You're very special.
I know.
So you need more folate because of the 677T, but you have to be careful because you're the 129.8. So you have to adjust. That's why I'm saying, like, people say, well, what do I do for this one? What do I do for this one? And I'm like, I can give you a protocol, but it's up for you to adjust. So the parabola where you're like, that revving up is typical.
Okay.
So,
I was coming out of my skin. I mean,
sure.
I felt great like the first 2 weeks.
That's where I would use
And
some,
then I was like,
exactly.
and I got
So.
muscle tested, and she's like, you only need this like 1 a week.
Right, so there's 2 theories to that, and we're going to talk about it. When we start supplementing with genome mutations, the theory is that you're supposed to be increasing methylation as you keep taking your supplements. In theory, you should need less vitamins then, right? Because you're revving it up, the body's up, it's like, hey, okay, all right, I'm running. So you find your magic amount. Initially, when they first started feeding your cycles, you were like, oh, I feel great. And then all of a sudden it was like, back it down a little bit. So that parabola we're going to talk about is when you are working with clients, you get them to this point where they're like, I feel great. And then all of a sudden they start to feel bad and they think they need more. And so, right, because what happens, right, when you go to a personal trainer, you say, my weight loss stopped. What do they say? Work out more. Right? You go to a naturopath and you say, I'm just not feeling as good. Are you still taking your supplement? Yeah, well, maybe you need more. That's not the case with MTHFR. That's not the case with methylation. because you're supposed to be feeding this cycle, which eventually then as you cycle back around, it gets bigger and bigger and better and happier and more sustained. And if you keep giving it more, it's too much. It's like putting your foot on the gas. So that's probably what happened to you. There are some complementary things I would suggest, like CBD. Will calm the autonomic nervous system, feed the endocannabinoids. We can use other products to complement. Vitamin D, especially if you have the two, because it's a fat soluble, so it'll really help with the hormones, which is basically the neurotransmitters and the SAMe. So there's things that we're going to talk about complementary as well. Okay, so this is your path to glutathione. I just like to keep referring back to these so you guys keep getting that visual that this is B cycle, this is conversion of the protein to the methyl bodies that give and create other proteins into homocysteine, which is going to create down here glutathione. So low levels of glutathione, it causes a buildup of homocysteine in the blood, which is what they look for an indicator for heart issues. There's also an increase in sulfur in the urine and higher ammonia levels in the body. So people that have a methylation issue and they come in with these, they had their blood work done, it's showing these high levels, they're having joint aches, you may be testing their urine. I used to do RBTI, so I played with urine all day, and I remember some of them I would open and be like, wow. So these are some of the pathways that you can look at as indicators that the glutathione is low. And you can test and get that confirmed, or you might be a muscle tester or whatever that looks like in your practice. Okay, so what is the point of glutathione? It's obviously an antioxidant. It helps us with oxidative stress. So when your glutathione is low, you're not detoxifying. You may be experiencing allergies, fatigue, brain fog, poor memory, cardiovascular, joint pain, weight gain, autoimmune, cancer. Because if you're not getting bad cells out, they're going to go somewhere. Okay, so we went over cellular repair and detoxification. Let's talk about the immune system. Is everybody okay? We haven't even got into genetic mutations yet. I tried to make it fun, guys. I just can't. Okay, so low methylation leads to low cellular repair. We know that. You don't recover. It leads to low detoxification. We know that. You don't get bad things out. You don't recycle homocysteine appropriately. It builds up. You're not getting enough protein, which leads to bad cellular repair. And it plays a critical role in immune system due to this glutathione. So it supports the immune system to fight off bacteria, viruses, oxidized free radicals. And it's funny, have you watched the progression of our knowledge in health, right? 12, 15 years ago, we talked all about free radicals. Now here we are talking about methylation, and they fit in. Remember, every time you have a new concept in health, it's going to fit into a bigger picture somewhere. It never stops just one thing. Okay? So let's talk about tumors. Methylation is involved in the production of T cells that attack viruses, bacteria, and cancer cells. Low T cells lead to the accumulation of different infection and tumors. Research scientists have found DNA methylation to be abnormal in all forms of cancer. That line right there. All forms. The funny thing is, they don't understand how it happens. It's a mystery. And I'm like, I'm an ND from Tyrone. I know how this happens. Do we really not know how this happens? So I think, as we progress in medical, now this is from 2016, so just in 2 years, they went from not knowing how this happens to understanding that methylation is a pathway to chronic illness. In 2 years. Where will we be in 5? Okay, autoimmune disease. Methylation in DNA maintains cell function. An abnormal study about DNA methylation was deliberately created in animals. They actually tried by giving them medication, and it developed lupus. So what does that tell you about certain medications? Right? There are medications, and I have a list, it's in your PowerPoint, that will decrease methylation. And for people that have a genome mutation, it's very important to know which mutation they have and what medications interfere with methylation.